Alright, so what we have on the bench today is the Rockitt Retro 50 bass spec, and this is a super lead bass style or super bass style amp, and two EL34s, 3 preamp tubes. And what I've done is I've hooked it into my DSO here, and that's my signal generator. So the way the setup is right now is the signal generator is feeding into the input of the amp a 1 kilohertz sine wave, and the output of the amp goes into my Suhr Reactive Load here, and I'm just tapping in the DI out or line out into the input of my oscilloscope there. So that's the setup at the moment, and the reason why I had to bring this up on the bench today is, one, to check the bias, and there was a slight problem, and I will link a quick video of where the problem was. Here the preamp tube there is more or less causing a problem. Like if I just hit it, you can see how it kind of flutters, and I will need to replace that, and that was one of the reasons why I wanted to troubleshoot. In fact, I noticed that when the amp was hooked up to my guitar, and I was hearing a lot of scratchiness. What I've done is I've fixed that issue. I replaced this preamp tube with a known good one, and now when I tap, there's no fluctuation anywhere, and it's absolutely fine. So I'm assuming that that will also translate to no scratchy noise when I hook it up, and have a guitar plugged into it and all that. So I'll figure that out after this video is done, and I'll report back on how that works. The main intention of this video was to show you guys how to really understand if a set of power tubes are actually matched or not from a mathematical standpoint, but from a pure sine wave standpoint, from a signal standpoint. Now what we have here is a 1 kilohertz signal from the signal generator going into the amp, and like I said, and then out from the reactive load and into the oscilloscope there, right? So if I make a change to the volume control there, you will notice the signal going up and down and whatnot, right? So the way a plexi style amp works is it's a push-pull amplifier, right? Which means one of the power tubes feeds the positive signal and the other one feeds the negative signal. So if you look at it on the scope, on what that means, this is the center line, which is 0, right? And anything above that is the positive signal, and anything below this line is the negative signal, right? So if you look at it, it's so uniform. If you look at the divisions, it's perfectly in the right zone. So if I had to count, so we have 1, 2, and almost about 2.5, approximately just over 2.5 blocks above and positive signal, and if you had to look in the negative area, is exactly the same. So these two match perfectly, and that tells us in a visual setting that these amps, these tubes are perfectly matched and are good to use in an amp. You don't need to have a tube tester and all of those things in place to do it. If you have a simple oscilloscope, and you really don't have to play with all the high voltages that we have running in the in the amp, and probing certain areas which can be lethal. So just thought I would share that. Now if I just reduce the overall volume, the sine wave will nicely smooth out, right? And then just to make it larger and clearer to the eye, and adjustments so that the sine wave can really be nice and smooth with the right settings. Yeah, there we go. That's how, I mean, as I'm increasing the gain or the channel volume, it's kind of starting to get into a clipping zone. It would be interesting. I mean, I would want to kind of, you know, make a few more videos if you guys want, where I can add more drive pedals and stuff like that to, you know, to demonstrate how those things make a difference in the way the output looks like on an oscilloscope. So I hope you found this useful. And yeah, I mean, the idea was to just simply demonstrate how this can be done with an oscilloscope at home if you have one, and without the risks of touching anything inside there, you know, because it can be quite high, you know, heavy, really high voltages that we would be dealing with there. Thank you.